To survive in modern deserts, we rely on brute force. Deep well industrial pumps violently tear millions of gallons of water from the earth every single day, extracting it far faster than nature can replace it. This hydrological diagram shows the physical cost. On the right, active pumping draws the water table down into a sharp cone of depression. This aggressive extraction causes the water table to collapse and the land itself to subside. But away from the roaring machinery, out in the silent expanse of the desert, evidence remains of an entirely different strategy for survival. From the surface, they look like a mysterious line of pockmarks or craters stretching toward the horizon. In reality, these are the maintenance shafts for a passive infrastructure system pioneered over 3,000 years ago. Beneath these unforgiving landscapes lie tens of thousands of kilometers of hand-dug tunnels, silently delivering life-sustaining groundwater to isolated oases. They transport millions of gallons of water using zero electricity and not a single moving part. By working strictly within the physical limits of gravity, these ancient networks solved the crisis of arid survival, long before our modern, high-energy pumps began draining the aquifers dry. In a hyper-arid climate, atmospheric evaporation is a constant, invisible drain. In the Sahara, the sky can strip away over 2 meters of surface water in a single year, long before a drop of rain ever hits a thirsty crop. Nature's cistern is the geology of the foothills. When moisture-laden air hits mountainous terrain, it triggers rainfall. That water cascades down the slopes and rapidly filters into cone-shaped deposits of coarse gravel and sand known as alluvial fans. Coarse sediments allow the water to percolate deeply until it hits an impermeable bedrock layer. This traps vast reserves of pristine water in an unconfined aquifer, completely shielded from the evaporating sun. This cross-section shows how ancient engineers tapped into this hidden reservoir. Surveyors read the surface landscape, searching for deep-rooted desert vegetation, then dug a vertical mother well, seen here on the far left, straight down to test the aquifer's depth and yield. But locating the water was only the first step. The true challenge was transporting it dozens of kilometers across the desert plains without ever exposing it to the deadly atmospheric heat. The solution relied on the elegant physics of passive fluid dynamics. By maintaining a razor-thin hydraulic gradient, engineers could coax the water horizontally through the earth using only the continuous pull of gravity. The margins of error were microscopic. If the tunnel is dug too steeply, the kinetic energy of the rushing water causes severe erosion, scouring the floor until the entire gallery collapses. If the slope is too flat, the water stagnates. It fails to overcome the friction of the tunnel bed. Sediment settles, and the channel completely chokes. To prevent this, ancient surveyors maintained a remarkably precise 0.1% slope, often dropping just 1 meter for every kilometer of length. And they did it entirely underground, working in absolute dark with a weighted string plumb-bob and a cross-shaped groma to keep their lines straight. Where they encountered soft soils, they reinforced the walls with a traditional hydraulic mortar called sarouche. By chemically binding specific ratios of clay, limestone, ash, and egg whites, they engineered a water-impermeable composite that rivals modern cement in its longevity. By combining precise fluid mechanics with advanced material chemistry, these builders secured a continuous, cool transit of water, entirely isolated from the sun without relying on a single machine. While these systems were mastered and expanded across Eurasia by the Persian Empire, the underlying logic of subterranean engineering was a global human adaptation. Half a world away, in the hyper-arid coastal plains of South America, the pre-Inca Nazca civilization engineered their own distinct underground networks, known as puquios. Instead of straight vertical drops, the Nazca designed these striking, spiraling, funnel-shaped access shafts. These wide openings were perfectly engineered to catch the prevailing desert winds and push oxygenated air down into the underground galleries. From the Karez of the Chinese Silk Road to the fagaras of the Algerian Sahara, underground water harvesting was an essential, adaptable engineering strategy that allowed diverse civilizations to thrive in the most hostile environments on Earth. The Achaemenid Empire fell to Alexander the Great. The mighty Uyghur Khaganate collapsed. The Nazca culture faded into the coastal sands. Yet the water in their tunnels kept flowing. Why did this infrastructure outlast the mighty, centralized empires that built it? The survival of the system relied on how the water was managed. Unlike colossal monuments or palaces that required centralized state power to maintain, these water networks were decentralized and intimately tied to the daily survival of local communities. Because a gravity-fed tunnel only skims the naturally recharging surplus of an aquifer, output naturally drops during a drought. To prevent over-extraction, local administrators allocated water strictly by time, rather than by volume. To measure this equitably, designated water masters used attached, a precise water clock. The time it took for a perforated copper bowl to slowly fill and sink represented one standard unit of water for a farmer. Longevity requires more than just good engineering. The physical sustainability of the qanat was only possible because it was bound to an unbreakable social contract of equity. Over centuries of conflict and urban expansion, thousands of these ancient lifelines were abandoned and swallowed by shifting sand dunes. But today, modern hydrogeologists are utilizing cutting-edge science to unearth them. This graphic illustrates how researchers are feeding declassified Cold War-era spy satellite imagery into advanced deep learning AI. The algorithm scans the desert surface and automatically detects the geometric signatures of lost shafts with incredible precision. Deep beneath the earth, in dark, cool galleries carved by generations of laborers working by oil light, the water continues its silent journey to the surface. Ancient engineers built for longevity by working with gravity instead of fighting it. They prove that the most enduring human technologies are those that respectfully read the landscape and operate in quiet harmony with the earth.